So I'm going to move this. Hi, my name is Jessica Bryant, and my capstone was animating and 3D printing the cranial nerves, and my capstone mentor was Dr. Salcedo. And before I start, I just want to thank a few people, including Dr. Salcedo, my mentor, Dr. Thompson, my capstone chair, Jake Shear, my capstone committee member and Toltec liaison, Noah Lepic for all of his help with 3D modeling and printing, Touch of Life Technologies, again, Toltec for providing their data for this project, and the Modern Human Anatomy program for making it all possible. So just a little bit of context, the cranial nerves are 12 pairs of nerves important for head and neck anatomy. They have functions in general sensation, special senses like sight, smell, taste, hearing, balance, yet they lack a complete learning tool, even as heavily as they're taught and as important as they are anatomically and clinically. The common modes of learning the cranial nerves are through textbook images, like the one from Grant's Atlas of Anatomy shown over here. These are 2D, and they usually show the complete passage, but the true anatomy is in yellow here, with the idealized anatomy in color, which is not anatomically accurate. And then over here, this is taken directly from Toltec's virtual human dissector, showing after a craniotomy, it's the same view, this brain here and brain here, showing the roots of the cranial nerves that are cut here and the stems that continue through the skull and cranial cavity, but you can't get a complete passageway of your cranial nerves in dissection. So based on that, a complete learning tool would then, in theory, include hands-on learning and a 3D visualization, just like dissection based on real anatomy, while also showing the complete passage like textbook images are able to do, but in an anatomical way, which in theory, we decided a 3D model and some animations would likely check all those boxes. So that being said, with that rationale, this project sought to develop a virtual and 3D printed resource showing the cranial nerves in their complete passage from origin determination going through the skull, and that would represent a complete learning resource for the cranial nerves. Okay, so to start this project, we again went to Toltec and they provided their pre-existing visible human male data. And in their program, their segmenter, we went through, and you can kind of see, segmented out the skull and the cranial nerves from the rest of the anatomy and cleaned up existing segmentations. Those were then received as model files, as OBJs that could be put into programs like Maya, Substance Painter, ZBrush, all that to prepare the models for printing, for animating, to clean them up further from this to this. 3D printing occurred on a Formlabs Form 2 printer in elastic and flexible clear resins. And there was problems there, but I'll get into that later. But the animations and then were provided as a YouTube playlist with a survey to the first year MHA students, and the analyzed data shows a positive response so far. Based on that, this is the segmenter up here. This is Toltec's original visible human male data before editing. And after a few weeks and weekly check-ins, this shows the completed skull after the edited segmenting. And you can see that holes in the skull have been removed, holes in the orbit. And then those OBJs were provided by Toltec again. And we put those into Maya and ZBrush, Substance Painter for cleaning and retexturing, and came out with this final product here that was then further animated to highlight each individual cranial nerve. New materials were given for the skull and the nerves to move from this to more of a bone-like appearance. And then printing is shown here. That's the Form 2 printer. The skull completed after 41 hours successfully. The brainstem failed after about 19. About half of the cranial nerves failed to print, and we attribute that to maybe printing at anatomical scale. But we did get a second brainstem printed. I can show here. With many more nerves, it's much more complete, that we are hoping to get out to students as well. But the animations with distance learning and everything that was going on with COVID, we decided to focus primarily on the animation playlist. So the final result was a YouTube playlist of 15 animations, one for each cranial nerve and one for each division of trigeminal. And I attached one here that I'll start in a second, but we attached it with a consent form and a survey for students to fill out just regarding their overall impression, the effectiveness of the learning resource compared to those available, and the overall effectiveness. So attached here, I won't show the entire. So this one is highlighting the trochlear nerve, and all of the other nerves go transparent. Audio is also provided, but I didn't include that for the sake of the talk. So here's shown some of the early survey results. So we provided this in mid-March, and that was during the head and neck unit for students in neuroanatomy. But early data from the type form surveys are showing generally a very positive response to the animation playlist. And students are finding that the cranial nerve animations are more effective than the other resources available at about a 4.5, but the overall effectiveness is averaging right now at about a 4.4. So we sought to find the reasoning behind that as well. We analyzed the short answer trends that also went with that survey. There were 3 multiple choice and 2 short answers. And found that many of the students had the same feedback about the animations, that they enjoyed having a visual color-coded resource that shows the full cranial nerve, short videos that played continuously in an animation in order, highlighting anatomical relationships. But everybody also seemed to agree that the pauses in some of the videos were too long, more of the text could have been narrated, and I might even add some background music to stimulate the amygdala. I like that too, I like that idea. So we decided that that overall effectiveness of the videos may have dipped due to those long pauses and everything. So in an updated playlist, we're going to address the student feedback. The 3D printing of those cranial nerves may have failed due to printing at anatomical scale, but like I said, we just got another brainstem print out last week where we increased the nerve size by about 150%. So they just have a little bit more of a chance to make it through the print. But we decided the hypothesis cannot be fully evaluated until that 3D model is presented with the animations. So for future directions, we're also working with InWorks to get just another printout, because they could probably print the clear nerves with the clear skull, with the colored nerves all in one print. And we are printing still on the Form 2 to get a print to the students. We are updating all of the animations with the student feedback, and we will provide, hopefully before finals, when the students again have to review the cranial nerves and it is relevant to their learning, give them a new updated playlist with the cranial nerve models now that would be completed in a new survey as our future direction just for the end of the semester to fully evaluate the resource. So that is all we have so far. We are working diligently to get another printout. Are there any questions?
Great job, Jess.
Thanks. And that is the completed skull, and the new brainstem will be what we'll try to put it through there.
So do you have narration that are you explaining things during the as the students are looking at each nerve?
Yeah, I added audio describing the cranial fossa that the nerve is going through, the nucleus it comes from in the brainstem, just extra information that I also typed in a transcript that goes on the video. But the pauses between when I spoke and when the videos moved, students said that the pauses were too long generally. And so I'm going to cut those out so that students can pause the video on their own time. And just make the pauses themselves.
I had a question.
Yeah.
Awesome work. Thanks, Jess. This is great. I teach anatomy and phys, and so this is definitely something that's difficult to like transpire to someone else's mind if they don't get to see it. Right. How were you able to, and maybe this is a dumb question, so I'm sorry, but how were you able to like explain to the printer the differences in the sizes of the foramen for as the cranial nerves pass through them? Or was it just kind of like a standard, like small, medium, large kind of thing?
On the foramen, we again use that visible human male data from Toltec. So they have the skull pretty much almost segmented out. and we just made the foramen. And in a couple cases, when we put it into Maya or the editing software, it was kind of like, well, those cranial nerves don't fit. So we had to make the holes a little bigger, smaller to accommodate. Yeah. And especially since the nerves were just too small to print at anatomical scale in this little printer. Since we boosted up, the size of the nerves, we also have made the holes in the skull bigger to accommodate that, because that was a problem.
Yeah.
a-
Thank you.
Yeah.
I have a question.
Yeah.
So in the survey, the students reported that they found studying off of these animations to be, they felt they were more effective than studying off the cadaver or studying out of a textbook. Have you considered integrating the videos as sort of a walkthrough if they're holding a brain that they just performed a craniotomy on, or integrating them into a cadaver lab review experience?
That was ideal, was to get, I know neuroanatomy does dry labs as well. We could have done a wet lab, I assume, but to have the 3D printed models and the animations be a station in one of those dry labs or something, or even in gross anatomy, having them on a table, separate table with a QR code to the YouTube playlist so that they could do that in lab. Definitely all things we're considering. We're still going to hopefully do that, I think, at least when I get the 3D print completed, to provide with the QR to the new surveys.
Sounds fantastic. Incredible project.
Thank you.
Thank you, Jess. I think we
Thank
need to
you.
move on to
Yep.
our second speaker,